All right, in this video, we're going to look at question 7. It says, consider this series where we're summing 1 over n times n plus 1, and here n varies from 1 to infinity. So in expanded form, that's 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4, so on and so forth. Okay, so first thing I want to point out here is that this is not a geometric series. Okay, to see that, well, remember that a geometric series possesses this property that if I divide any two consecutive terms, I always will get the same number. But see here, if I divide the second term by the first term, which I'm doing right here, I get a third. But if I divide the third term by the second term, which I'm doing right here, I get a half. So there is not a common ratio for this series. It's not geometric. Okay, we're going to call this type of series a telescoping series, and I'll say more as to why that name is attached to it. But let's go ahead and look at part A first. It says, use the fact that 1 over n times n plus 1 is equal to 1 over n minus 1 over n plus 1 to find an expression for the nth partial sum s sub n. Okay, so why is this true? Well, you could, of course, just verify that it's true by combining these two terms and showing algebraically that, yes, they do combine to 1 over n times n plus 1. Or if you recall from Calc 2, you could start with this expression and break it up using partial fractions to get this resulting expression. But in any event, okay, these two expressions are equal, and so that says that the given series is equal to the sum of 1 over n minus 1 over n plus 1. So writing that out in expanded form, we're looking at 1 minus a half plus a half minus a third plus a third minus a fourth, so on and so forth. Okay, so now our job is to find an expression for the nth partial sum s sub n. So here I'm just writing out the first few partial sums. So s1, that's just the first term, so 1 minus a half. s2, that's where we're adding together the first two terms, so 1 minus a half plus a half minus a third. s3, add up the first three terms, 1 minus a half plus a half minus a third plus a third minus a fourth, so on and so forth. All right, so now the thing to note is that we get a whole bunch of nice cancellation in these partial sums. So for s2, the halves cancel out, and I'm left with just 1 minus a third. For s3, the halves cancel out, and the thirds cancel out, leaving us with 1 minus a quarter. s4, halves cancel, the thirds cancel, and the quarters cancel, leaving us with 1 minus a fifth. Okay, so notice that this denominator you see in the simplified expression is always 1 more than the index for the partial sum. So for s4, it's 1 minus a fifth. For s3, it's 1 minus a quarter. Okay, so in general, for s sub n, it will be 1 minus 1 over n plus 1. Okay, now we say that the partial sums, right, they collapse. And if you've used or seen one of these old-time telescopes, okay, they have legs that kind of collapse in on themselves just to make storage easier. It's kind of like a collapsing tripod, maybe, if you use one of those. That's historically why this name telescoping is attached to a sum like this. Okay, we get all this collapse of the terms in the middle, and we're in this case just left with the first and the last term that remain. Okay, now part B says use part A to find the sum of the series, and now that we know what s sub n is, there's really nothing to this, because by definition, right, the sum of the series is equal to the limit of its partial sums, and since we now know that s sub n is 1 minus 1 over n plus 1, I can take the limit of this expression as n approaches infinity, and that gives me a sum equal to 1. All right, so that's going to do it. In the next video, we'll look at a few more examples of telescoping series. Thanks so much.